Hello children, so I'm back with my next video. So in this video we'll be discussing about the concept of energy and what are the different forms of energy and about potential and kinetic energy, their equational derivation. So when we say energy, what is energy? You know that if someone says that he is having energy, that means he is having a capacity of doing some kind of work. He may or may not do work, but he will have the capacity of doing work. So energy can be defined as the capacity of a body to do some work. So since it is the capacity of a body to do work, therefore we consider energy and work done to be equivalent. Not same, but equivalent. And therefore the SI unit of energy is same as that of your work done, that is joule, and CGS unit is erg. So energy can be considered equivalent to work done since energy used helps us in doing a work. When you'll be doing some work, you will be using energy. So what is the definition? Now in work done, we have got that SI unit of work done is joule. So what is the definition of joule? So when someone asks you that define joule, you are actually being asked to define 1 joule. So how do we define that? Work is equal to F into S, that is your force into displacement. So the work done will be 1 joule when the force will be 1 Newton and the displacement will be 1 meter. So 1 joule is 1 Newton meter. Therefore, so from this we can write the statement that the work done by a body is said to be 1 joule when on applying a force of 1 Newton. Suppose there is a body and you are displacing this body over 1 meter, and while doing so, if you are utilizing how much force? 1 Newton, then you are said to use up, or you are said to have done 1 joule of work. So on applying a force of 1 Newton, the displacement caused is 1 meter. So what is the relationship between joule and erg? So work is equal to F into S, force into displacement. So work done is 1 joule. So 1 joule is 1 Newton into 1 meter. 1 Newton you have got in the earlier chapter that 1 Newton is equal to 10 to the power 5 dynes. 1 meter is 100 centimeter, that is 10 to the power 2 centimeter. So 10 to the power 5, 10 to the power 2. So 5 plus 2 is 7. So it is 10 to the power 7 dyne centimeter, which is also known as 10 to the power 7 erg. So this is the basic concept of energy and its unit. Next we will be looking into the different forms of energy. So when we are talking about different forms of energy, so in our surroundings we have different forms of energy. So for example, like solar energy, because you know the energy from the sun, it can be either light energy or heat energy. Mechanical energy is due to some kind of movement or position or shape. So the mechanical energy has got two forms, potential energy and kinetic energy. Next we have wind energy, light energy, thermal or heat energy, nuclear energy, muscular energy. Suppose you are doing some kind of work physically, so that involves muscular energy, tidal energy, high tide, low tide of the seas, hydro energy, and sound energy. So all these are hydro energy, means the energy tapped from flowing river, so that is your hydropower. So these are the different forms of energy. Now we should know that the different forms of energy are interchangeable. So that transformation of energy in different cases, what are the different transformation of energy which takes place? Here I have cited few examples, so we'll be discussing those examples. So for example, an electric bulb. So in case of an electric bulb, we know that electrical energy is converted into light and heat energy. So the earlier filament bulb, the yellow color filament bulb, a lot of heat energy was produced, but nowadays we have LED bulbs or LED lights. So the amount of heat energy is very less, so most of the electrical energy is converted into light energy. Next we come to the case of dam, hydropower. So what happens in case of a dam? You know, a flowing river is blocked by a wall, a dam wall, and the level of the river will rise behind the dam wall. So that means the energy that is potential energy which is building up, potential energy because of the height of the water. Now when the gates will be opened, the water will start flowing out, so that flowing water is said to possess kinetic energy, and ultimately that flowing water will rotate the turbine and the generator will generate electrical energy. So potential to kinetic, kinetic to electrical energy. Fan, you know, electrical energy. So as soon as you switch on a fan, it is electrical energy, then the fan starts rotating, that's kinetic energy, and then you get wind energy. Next is the steam engine. Steam engine only doesn't mean the engine which pulls a train. Steam engine is mostly used in thermal power plants where the coal is burned, and after burning the coal, the heat which will be formed, that will be used to heat up water. So when the water will get converted into steam, the steam will come out at high pressure, and that pressure is used to rotate the turbine, and electricity can be generated. So in steam engine, what happens? Chemical energy. Chemical energy means the energy stored in coal or whatever may be the source. When it is burnt, you get heat energy, and heat energy is converted into kinetic energy. Now we can use this kinetic energy to pull a train, or we can use it to run machines. We can use it to generate electricity. Whatever we want, we can do. So next is winding the key of a toy car or a toy. So you have seen toys where we have a key to be turned. Turning the key means there's a spring inside the toy which gets coiled up, and so you are using your muscular energy, and as you use your muscular energy, there's a spring inside the toy, and this coil spring, the more you turn it, the more it gets compressed like this, and it has got develops a potential energy. As soon as you release the key, it turns back to its original position, and you get kinetic energy. For example, suppose there's a toy car. Okay, so there's a toy car, and suppose there's the wheel. I'm using my muscular energy to rotate the wheels, and these wheels are connected with a spring inside. So my muscular energy has got converted into potential energy. As soon as I will release it, the spring will go back to its original position, and so my muscular energy ultimately is getting converted into what? Kinetic energy. So these are some of the examples of different forms of energy. So now we'll be looking at potential and kinetic energy and what is their equational form. So what is mechanical energy? So the definition goes like this, that mechanical energy possessed in a body is by the virtue of its position or motion. Suppose you lift a stone to a certain height. So that stone, when it will fall, it will have a capacity of doing some work. So that is called your potential energy. And suppose that same stone you are throwing towards a glass. So that moving stone will also have a capacity to break that glass. So that is also having a capacity to do work. So the energy which will be possessed in a body by virtue of either its position. Suppose our position means it can be shape also. Suppose a rubber band. You're pulling the rubber band, so that stretched out rubber band has a capacity of doing some work. So by virtue of its position or motion is called mechanical energy. So it is of two forms. One is potential energy, another one is kinetic energy. So what is potential energy? Potential energy is the energy possessed in a body by virtue of its position or shape, you can say. Okay. I gave you the example little while ago that lifting a stone up to a certain height. At that height, the stone will have a potential. What is the literal meaning of the word potential? Your capacity to do some kind of work, that is called potential energy. So how do we derive the equation? Let us consider a body having mass m. Okay, it is lifted to a height h, and at that position it is under the influence of acceleration due to gravity small g. So as we discussed before, energy is nothing but equivalent to work done. So potential energy is equal to work done. So work done is, we have got the equation F into S. So F is ma from the second equation of second law of motion, Newton's second law of motion. F is equal to ma. So we can write ma and S. So instead of a, since it is a case of height and it is under the acceleration due to gravity g, so instead of a I can write g, and instead of s we can write h. So potential energy can be written as mgh. This is the equation for potential energy for any body which is lifted up to a certain height. Suppose this pen I have lifted to a height. As soon as I release, it has a potential to fall down. Next, kinetic energy. So when we are talking about kinetic energy, kinetic means what? Something which is in motion. Okay, so kinetic energy is the energy possessed in a body by virtue of its motion. So the let us consider this case. Suppose this is a body which is initially at rest, so initial velocity is 0, and we apply a force F on this body. After applying a force F on this body, the body gets displaced through a certain distance, and let's say the distance is S, and the final velocity after traveling a certain distances, the final velocity of the body becomes V. So kinetic energy, just like potential energy equivalent was work done, here also we have taken kinetic energy is equal to work done. So work done is F into S. So instead of F, I have written ma, and S will try to replace it from the third equation of motion. Third equation of motion is V square minus E square is equal to twice AS. So I need S, so I'll separate the S. So this twice A I will bring it below here. So it will become V square minus U square by twice A. So U square becomes 0. So ultimately S becomes S is equal to V square by twice A. So A and A, when I'll replace this here, instead of S I'm writing V square by twice A and A cancels out. So I'm left with mv square by 2. So anything divided by 2 means what? It is half, so I'm bringing that constant out. So the equation for kinetic energy becomes half mv square. So these are the two forms of mechanical energy, potential and kinetic energy, and their equation. So if you have liked the understanding, the concepts that I have discussed, you can like the video, you can share the video, and just wait for my next video where I'll be discussing about the law of conservation of energy. Till then, bye bye, kinetic energy.